Hello guys, today we are going to discuss about how to balance a redox reaction by using ion electron method. Okay, ion electron method is also called half reaction method. Okay, so in my previous videos we have discussed about redox reaction, oxidation and reduction. Okay, all these things we have discussed in my previous videos. Okay, so today in this video we shall discuss how to balance any redox reaction by using this ion electron method, or you can say half reaction method. Okay, so today we shall discuss in this video. And if you don't know about redox reaction, oxidation, reduction, then please watch my previous videos. Okay, and also I shall provide the link of that videos in my description box. You please check. Okay, so now let us start. Actually there are certain rules for ion electron method or half reaction method to balance any redox reaction. Okay, and these rules will help us to balance the redox reaction. Okay, so first of all we shall discuss the rules one by one, and then we shall move to the balancing of a redox reaction. Okay, so now you see the rules. Before that, if you are new on my channel, then please subscribe my channel and press the bell icon so that you will get notification when I shall upload my new video. Okay, so now let us begin the video. Now see, balancing of a redox reaction by ion electron method or half reaction method. Okay, the following rules are used to balance the redox reaction by ion electron method. Okay, as I have already told you, there are certain rules for ion electron method which will help us to balance of the redox reaction. Okay, so now you see the rule number 1. The rule number 1 is that two half cell reaction, that is oxidation half and reduction half, write separately. Okay, means we have to write oxidation half and reduction half separately. Okay, we cannot write together. Now first of all you have to know this term oxidation half and reduction half. What is oxidation half and reduction half? So oxidation half and reduction half is nothing but the substance which will get oxidized, that substance will be called oxidation half, and the substance which will get reduced, that substance will be called reduction half. Okay, so we have to write oxidation half and reduction half separately. This is the rule number 1. Okay, so now come to the rule number 2. So rule number 2 is that in acidic medium always H positive at left side of the reduction half and right side of the oxidation half if it is necessary, which is balanced by water in opposite side. Okay, that is, if the redox reaction is in acidic medium, then we have to add H positive in the left side of the reduction half. Okay, and if it will need, then we have to add one another H positive in the right side of the oxidation half. Okay, and then after, at the same time, we have to add water in the opposite side. Okay, that is, if we add H positive in the left side of the reduction half, then we have to add water in the right side of the reduction half. Okay, so this is rule number 2. Now come to the rule number 3. So rule number 3 is that in basic medium always negative add to the right side of the reduction half and left side of the oxidation half if it is necessary, which is balanced by water in opposite side. Okay, that is in case of basic medium. Okay, that is if the redox reaction is in the basic medium, then we have to add OH negative in the right side of the reduction half. Okay, and then if it will need, then we have to add another OH negative in the left side of the oxidation half. Okay, and then after at the same time we have to add water, that is H2O, in opposite side. Okay, that is if we add OH negative in the right side of the reduction half, then at the same time we have to add water in the left side of the reduction half. Okay, so this is the rule number 3. Okay, now come to the rule number 4. So rule number 4 is that electron always at left side of the reduction half and right side of the oxidation half, which do not depend on the medium. Okay, that is we have to add electron always left side of the reduction half and right side of the oxidation half. Okay, addition of electron does not depend upon the medium, whether it is a acidic medium or it is a basic medium. It does not depend upon the medium. Okay, we have to add electron always left side of the reduction half and right side of the oxidation half. Okay, so this is the rule number 4. Okay, now come to the rule number 5. So the rule number 5 is that is the last rule of ion electron method, is that two half cell reaction are added in such a way that electron should be cancelled. Okay, that is in the last step we have to add the two half cell reaction. Okay, that is in the first rule it is given that we have to write the separately the two half cell reaction. Okay, that is in oxidation half and reduction half we have to write separately. So in the last step again we have to add these two half cell. Okay, that is oxidation half and reduction half we have to add in the last step, and we have to add these two half cell reaction in such a way that electron should get cancelled. Okay, okay, so this is the rule number 5. So now let us take one example. Okay, how to balance a redox reaction by using these 5 rules. Okay, so let me take one example. So let us consider this reaction, and it is given that this reaction is in the basic medium. Okay, so we have to balance this redox reaction in basic medium, not in acidic medium. Okay, it is given that. Okay, now first of all you have to find the oxidation number of each compound present in this reaction. Okay, so now you see the oxidation number of Mn in this compound is +7. Okay, and in this I negative ion, the oxidation number of this ion is -1. Okay, and in this product form, that is in this compound, the oxidation number of Mn is +4. Okay, and this oxidation number of I2 is 0. Okay, so if you don't know how to find oxidation number, then please watch my previous video. We have discussed in my previous videos how to calculate oxidation number of an element. Okay, so you see here the oxidation number of Mn decreases. Okay, because here you see oxidation number of Mn is +7, but in the product form oxidation number of Mn is +4. So obviously the oxidation number of Mn decreases from +7 to +4. Okay, and we know if the oxidation number of any element decreases, then that element will get reduced. Okay, so here in this case Mn will get reduced. Okay, because the oxidation number of Mn decreases from +7 to +4, and you see the oxidation number of this I negative ion is increases. That is, from here you see oxidation number of I negative ion is -1, but in the oxidation number of I2 here in the product form is 0. That is increases from -1 to 0. Okay, and we know if the oxidation number of any element increases, then that element will get oxidized. Okay, so in this case this element get oxidized. Okay, so now come to the rule number 1. What was our rule number 1? We have to write the half cell reaction separately. That is oxidation half and reduction half we have to write separately. So here this one is half cell reduction half. Okay, this Mn of 1 negative is reduction half because it is get reduced. Okay, and this I negative is oxidation half because it is get oxidized. Okay, so we have to write these two in separately. Okay, according to rule number 1. So let me write reduction half. Okay, so reduction half is MnO4 negative. Okay, then in the product form MnO2. Okay, and then oxidation half is, we have to write in this way, oxidation half and reduction half. Okay, and oxidation half is this one is oxidation half, so I negative. Okay, and that gives I2. Okay, so now our rule number is completed. Now you come to the rule number 2. You see in rule number 2 in acidic medium, so we don't need this rule number 2 because our reaction is in basic medium, so we have to apply the rule of basic medium. So we have directly come to the rule number 3 because we don't need rule number 2. It is for basic acidic medium. Okay, so we need the basic medium, so we shall apply this rule. So now you see in rule number 3, in basic medium always OH negative add to the right side of the reduction half. Okay, so you see we have to add OH in the right side of the reduction half according to rule number 3. So here you see reduction half is this one is reduction half, so we have to add OH in the right side of the reduction half. So this one is left side and this one is right side, so we have to add OH negative here. Okay, and at the same time we have to add water in the opposite side, that is in the left side, according to rule number 3. Okay, so here we have to add H2O. Okay, so this is our rule number 3. And in the oxidation half we don't need to add OH, okay, because it is not necessary. Only iodine atom is present in both sides. Okay, so we don't need to add OH negative in the oxidation half. Okay, so now we have to balance the number of each atom in both sides. Okay, so you see in the left side how many oxygen atom is present, that is number of oxygen atom in left side, that is in the reactant form, is 5. Okay, here 4 number of oxygen atom is present and here 1 oxygen atom is present, so total is 5. But in the right side you see here 2 number of oxygen atom is present and here 1 number of oxygen atom is present, that is total is 3. So here total is 5 and here total is 3, so we have to balance this number of oxygen atom in both sides. Okay, so if we multiply by 2 here, then now number of oxygen atom has become 6. Okay, here 4 and here 2, so again we have to multiply by 4 here also, then only the oxygen number of oxygen atom will be balanced. Now you see in the left side the number of oxygen atom is 6, 4 and 2 plus 6, and in the right side also number of oxygen atom is 6. Here you see number of oxygen atom is 2 and here number of oxygen atom is 4, so total is 6. Okay, now number of oxygen atom has balanced. Now you see the number of hydrogen atom. In the left side number of hydrogen atom is 4 and in the right side also the number of hydrogen atom is 4, so it is already in balance. Okay, and again you see the number of manganese atom. In the left side number of manganese atom is 1 and also in the right side the number of manganese atom is also 1, so it is also in balance. Okay, now you have to balance the oxidation half. So here in the right side 2 number of iodine atom is present, so we have to simply multiply by 2 here, then the number of iodine atom will be balanced. Okay, so now we have balanced this oxidation half and reduction half. Now we have to add electron, that is rule number 4. You see according to rule number 4, electron always at left side of the reduction half and right side of the oxidation half, which do not depend on the medium. So we have to add now number of electron. Okay, so left side of the reduction half and right side of the oxidation half. Okay, so you see in the right side of reduction half 4 negative ion is present. Okay, 4 negative ion is present and in the left side 1 negative ion is present. Okay, so we have to add 3 electron in reduction half, and according to reduction half according to rule number 4, we have to add electron in the left side of the reduction half. You see in the left side of the reduction half. Okay, so we have to add here 3 electron in the left side of the reduction half. Okay, now come to the oxidation half. Here you see 2 negative ion is present, but in the right side no ion is present. So to balance this negative ion we have to add in the right side of the oxidation half 2 electron. Okay, so we have to add 2 electron in the right side of the oxidation half according to rule number 4. Okay. Okay, now come to the rule number 5. You see, according to rule number 5, two half cell reaction are added in such a way that electron should be cancelled. Okay, now according to rule number 5, we have to add these two half cell. Okay, that is reduction half and oxidation half. So we have to add these two half cell in such a way that this number of electron and this number of electron should get cancelled. Okay, so you see in the reduction half number of electron is 3, but in the oxidation half number of electron is 2. Okay, so we have to eliminate this number of electron after adding. Okay, so how we shall eliminate this number of electron in both this half cell? Okay, so now you see, if we multiply by 2, first of all, if we let this reaction as equation 1 and this as equation 2, then if we multiply by 2 here, and if we multiply by 3 here, then the number of electron will get cancelled. You see here, 3 into 2 become 6, that is 6 electron, and here also you see 2 into 3, that is 6. So in the both cell the number of electron will become 6. Okay, that is the number of electron will be cancelled. Okay, if we add. Okay, so now let me add these two half cell reaction. Okay, so adding. So this will become 2MnO4 negative because we have multiplied by 2, equation 1. Okay, so 2MnO4 negative. Okay, and this will become 4H2O, and this will become plus 6 electron. Okay, and then at the same time we have to add the left side of oxidation half also. So here plus, here 6, this 2 will become 6 because we have multiplied by 3, equation 2. So this will become 6 I negative. Okay, now we have to write the right side of this, both these two half cell. Okay, so this will become 2MnO2 plus this will become 8OH negative. Okay, and this will become 3 plus 3 I negative, and plus this will become 6 electron. Okay, now you see this 6 electron and 6 electron in both sides will get cancelled. So our reaction will be 2MnO4 negative plus 4H2O plus 6 I negative gives 2MnO2 plus 8OH negative plus 3I2. Okay, so this is the required balance equation. Okay, so by using these 5 rules you can balance any redox reaction in acidic medium or basic medium. Okay, I think valency of a redox reaction is clear by ion electron method, or you can say half reaction method. Okay, so see you on my next video. Thank you for watching.